Welcome back. Good afternoon, everyone. I'm Steve.
And I'm Scott.
And we are in the backyard. Together, we're Backyard Musings.
Yep, feeling a little better today in the backyard. And we're the Science and Technology channel. And thank you again to the people that have been subscribing to our channel. It's cool. Very cool. So
I keep telling Scott he's doing something right. So keep doing it, Scott, whatever you're doing.
Butchering those words and names.
Okay, a new composite material passively keeps solar panels cool, boosting power output by 13% and extending their lifespan by more than 200%. And at the end of the slide,
I would have never thought this. You have to keep the panel cooler and it'll produce more power.
And you'll see at the end of the slide, we're going to show all the losses that you'll find from a solar system, inverters, conductors, panels, and cooling, the heating up is the biggest loss of power.
Wow.
You're going to see that.
Yeah, on the slide. Yeah.
Yep. An international team of researchers led by King Abdullah University of Science and Technology in Saudi Arabia has developed a new acrylate-based composite material that improves the performance of solar cells. When applied to solar cells, well, they got plenty of sun over there, right?
Well, yeah, and open area, right?
Yeah.
Have you ever been there?
No. I cannot tell you whether I have or have not. I have to kill you.
Oh, okay. Well, but you've been in similar
yes.
geographical
Kuwait,
areas,
Iraq.
Right?
Yeah.
Do they have solar farms like we have them?
No.
Or they're just all over the place?
No.
They don't do that, huh?
No.
Okay.
No.
Interesting.
Yeah.
Okay.
When applied to solar cells operating in Saudi Arabia for several weeks, the material significantly increased power output and lifespan while lowering the amount of electricity the cells used. The findings were published on May 16, 2025 in the journal Materials, Science, and Engineering. Would you like to know more?
Solar energy is a key focus for green economies around the world. Obviously not that part of the world, like you said, though. With solar cells making up more than 3/4 of all renewable energy installations. However, delivering reliable and long-lasting solar power presents significant challenges. So like I was just asking you, you can't drive anywhere in the desert Southwest and not see acres and acres and acres of some type of a solar farm.
Definitely, I can't speak about Arizona or New Mexico.
Yeah, you drive on the 10 freeway heading down to like the
they're
Phoenix
all out
area.
there.
Oh, they're building them and they're everywhere. Yeah.
There's
California,
a push
Arizona,
for green energy, I guess. Yeah. And you don't have to worry about freezing like in Texas. You do.
And why are we not being subsidized because of all that? You know,
well, somebody's getting. You mean we, the consumer?
The consumer, yeah.
Somebody's getting money. Somebody's getting subsidized.
Yeah. So, like, if we have any listeners from Las Vegas or Nevada, I've always heard that the casinos, because of the power usage that they take, subsidize the power in
the Hoover Dam
in Las Vegas.
They get the power from the Hoover Dam.
Well, okay, but it's still it's costly, right? I mean, it costs money. We get power from Hoover Dam too, I think. Arizona gets power from Hoover Dam, but I've heard it's subsidized, so their rates are lower. So there's a lot less people living in. I mean, there's a lot of people that live in Las Vegas, that Las Vegas Henderson area, but there's tons of people living here. Why are we not being subsidized by that? Why are we getting hosed by Southern California Edison? There's more solar today than there was 20 years ago, right?
Don't even get me started on SoCal Edison.
I know.
Don't even get me.
I'm surprised I even used their name. They organize crime. But anyway.
That's the best way to put it. Organized crime.
Yeah, they are.
You know what? I'm on my soapbox right now. You know what? They don't even have a customer service line that you can call and talk to someone about what I'm trying to get a permission to operate because I upgraded a year ago. I upgraded the equipment, added the batteries. I'm still trying to get that permission to operate because I put the application in. Somebody looks at it and says, this is wrong, kicks it back. I fix it. They look at it. This is wrong, kicks it back. And piecemeal. I mean, cutting me, nickel and diming me to death. Yeah. Still, I don't have it.
Yeah, because they don't care. They're like Medicare.
And I can't get the rebate until I get the permission to operate. Don't even.
Yeah, and like you say, unless you have hours and hours to devote to sitting on hold.
There's no number to call. I would call. I would sit on hold.
You can't call their customer service line?
No. There's a number. You call, leave a message, and we'll get back to you in 2 to 3 days.
Starting when?
I guess time when you leave the message, when you hang up. and it gets recorded.
Yeah.
Okay.
Let's bring it down back to solar cooled panels. Here we go.
Commercial solar panels convert only about 20% of sunlight into electricity. I don't know if that's true. I will dispute that. That doesn't 20% efficiency. No, 80%.
Oh yeah.
While the rest is either absorbed as heat or reflected. This heat lowers the performance and shortens the lifespan of the panels, leading to earlier replacement. As a result, cooling is essential. But traditional systems like fans and pumps require electricity.
Passive cooling offers an alternative that does not consume energy. Quote, we specialize in materials that enable passive cooling. These materials are thin and can be placed on different systems that require cooling to operate, like greenhouses and solar panels or solar cells, without affecting a performance, says KAUST professor. Here we go. Kyo Quing Jan, who led the study.
Mm-hmm. In the new study conducted through the KAUST Center, KAUST Center of Excellence for Renewable Energy and Storage Technologies, Gann and his colleagues developed a hygroscopic material made from lithium chloride. Oh, lithium, that's pricey. And sodium polyacrylate. This material absorbs moisture from the air at night. Well, there's not much moisture in Saudi or Iraq. And releases it during the day. Why would it release it? Why not keep that moisture and convert it to send it somewhere else, like a storage tank? And releases it during the day. Polyacrylate is an inexpensive polymer, and the fabrication process does not require harmful chemicals or specialized reagents, unlike other hygroscopic materials used for cooling. This makes the composite more cost-effective.
Okay. While operating for weeks in the Saudi desert, solar cells with this material adhered to them were 9.4 degrees cooler. That's Celsius, right?
Yeah, that's big.
So yeah,
bigger than Fahrenheit.
Yeah. Than those without the new material. They also showed an increased power output of more than 12% and an increased lifespan of more than 200%. Well, that's huge. Because I never really think about that either. What is a lifespan of
we got a
solar panel?
10-year warranty on the panels. Normally that's what you get.
So, but I mean, are they going to last longer than 10 years? I hope so.
Maybe,
it's like a car, right?
But by the time 10 years comes by, the power of a normal panel has, like, I started with 300 kilowatts. Now they're making like 700 kilowatt panels, and that was 7 years ago. So it's like computer chips. They're just
improving all the time.
Smaller
and better.
Yeah.
Their lifespan of more than 200% while reducing their cost generating electricity by nearly 20%. So, okay.
In addition to, now you'd think, there's so much sunlight over there. It can get to 130 degrees in Kuwait. Iraq was like 125. Kuwait was 130.
It's the summertime.
Yeah. So, in addition to Saudi Arabia, experiments were done in some of the coolest parts of the mainland United States under rainfall to prove that the passive cooling technology works in any environment. Gann tested the composite material on solar cells provided by KAUST professor Stefan de Wolf, whose research team has regularly achieved world records in solar cell performance through their customized designs.
Quote, this work is an excellent example of combining different expertise at KAUST. We tested the new cooling technology on top-performing solar cells in multiple environments and saw excellent results in every case, said de Wolf.
Okay, so we're going to throw up this slide here. Let me get it on there.
Yeah, this is like
I snipped this from Helioscope. Helioscope, everybody uses Helioscope for when they design their panels, what way it's going to face and the elevation and configuration. And this just points out how much loss you get in a system. And you can see temperature at the bottom is the biggest loss. Optimal tilt and orientation. So panels should be tilted at the latitude of the installation and oriented towards the equator to maximize incident irradiance. So I had to look up irradiance because I really didn't know what that was. And then clipping, I've experienced clipping. Inverters may clip the output to prevent overcharging the battery, which can lead to a loss of energy. Sometimes the inverter is improperly sized and less energy that is produced that can be produced. So it'd be
Undersizing it. That's wrong.
right. Well,
That's
it's an accident. Yeah.
Well, is it
Somebody-
an accident or they do it on
No.
purpose? Because then you'll come back and say,
No, it's your salesman.
man, maybe I need some more panels. Yeah, you need more panels.
Yeah, but I've got exactly. But
Trying
if you
to
have an app
upsell.
that shows you, my app shows me. Usually, it's a bell, upside down bell. But when it's clipped, it starts out at a bell and then goes across and then comes back down. You're like, what is going
below the
on?
line, right?
Yeah, what's going on? Why am I not capturing that top, part of the bell? Because the inverter's undersized.
Yeah.
Okay.
Wrong.
Why don't you do shading?
Shading can totally be prevented by trimming trees close to the panels. Soiling can be prevented by regular cleaning of the panels.
So there's some things you can do to,
Have you ever cleaned your panels?
I have. I've had Angel come over. I pay him to clean them.
So what do you do? Just hose them off?
Hose them off. I was using soap, and then because it's long, so I had this like telescopic,
Like a pool
like,
cleaning
yeah,
device?
it had a scrub on the bottom. Flip it over, and it's got a squeegee, and so I do that, and I was like, that's a lot of effort. So I just got the sprayer out, and
Pressure washer?
yeah, and try and push the dirt off.
I've seen some improvised or maybe even marketed devices where they have a pipe that goes across the upside and then it just sprays water and it just washes it off.
Yeah, that's if they're inclined,
Right,
on a roof. If on a roof, that'd be perfect.
Right, or a grid.
Yeah, I don't have much of a slope on mine.
Right.
Because it's like a pergola. It's like.
And have you noticed an uptick in the performance
Yeah.
when you clean them?
Yeah. Yeah.
We're now going into this is our third summer and I have yet to clean mine. So
Well,
maybe I should do
it
that.
shows 3%, right? So yeah.
Yeah.
All this, the wiring, you can lose power in the wiring, conductors,
So ours are monitored by, we have an app that we monitor them.
Yep.
And then the company also monitors them, and
Yeah.
they will send us notices and say, hey,
Yeah,
you got a
something's
problem with
wrong.
one of your panels, or this is not working or whatever. So, because we called the other day and asked the guy, and so here was my story. Not that we want to continue this segment too long, but my story was I heard all these people about putting in the solar system, and then at the end of the year, Edison says, well, you still owe us $1,200 or $1,500 or whatever it is. Yeah.
Whoa.
And you can pay that off, I guess, throughout the year, but normally it's hit at the end of the year. And I told the guy, I go, I am not investing in these things if I got to pay Edison at the end of the year any money. So he sized it. I forget what the percentage above, so we called him the other day.
Yeah,
and mine's on a grid.
panels.
Yeah, mine's on a grid.
Mhm.
I've got room for 3 more panels, but he said, no, I wouldn't put in 3, put in 2. And then you'll be sitting just right if you plan on doing anything else like pool.
It's $1,500 per
or
panel.
whatever.
Furnished and installed. It's $3,000.
Well, I'll tell you offline how much it was going to be from the company that we go, because it was probably about half that,
Oh,
like $600 a panel.
let me get with that guy. Yeah, give
I'll
me his
I'll
information.
tell you who it is. Yeah.
Yeah.
So anyway, I thought that that was cool. That's the kind of thing I want. I don't want a guy who goes, oh yeah, get the 3 panels, max out your grid. This guy's been really cool to us, and I will gladly give you his information because he's been good. And it's kind of weird the way the whole thing started, and I'll explain to that offline too. But so anyway, I've gone from 3 years ago to not being a solar guy to being on board with this, because I think if you do it right and you get with the right people,
You size it correctly.
you can get it can save you a lot of money. Because like we said before, electric bills around here in the summertime can be
$1,000,
thousands
$1,500
plus
depending.
a month,
Yeah.
a month.
How big your house is,
I mean,
how much you're cooling.
yeah, and
Parents are living with you. You got to keep them cool.
so it like I say, we say organized crime with our electric company here. It's ridiculous. So anyway,
coming back to this, so the optimizers, that's what if there's a power surge, the optimizer will stop the production. So you lose a little bit of power from the optimizers. The inverters, you lose power inside the inverters, because there's circuitry and stuff. The AC system, that's the copper conductors. The wiring is the DC, going from solar panel to the inverter. So you're losing power in there just from resistance, ohms, shading, we talked about that. Reflection, the sun reflecting off, that's a big one. I mean, wish they could do something with reflection,
Yeah. So what about the AC system? That just seems like very low.
Yeah, that's the wiring. I mean, wiring. It's the same. The AC and the wiring. AC is the copper conductors. The wiring is the DC side.
Gotcha.
Because there's DC and AC.
So that would be something eventually you may have to upgrade, right?
Or they make superconducting wires. We've talked about that on our segments.
Yeah.
Superconductors. That's the only way you're going to eliminate that.
Yeah. This is good information.
Yeah.
Good stuff here that they put out here on this chart.
Helioscope. Yeah.
Nice.
All right, folks. So let me remove this so you can see
Enjoy
our
your
chicklets.
Sabbath tomorrow.
We'll see you.
Yeah, now Steve's all happy now. Compared to how he started out.
That's
Take care.
bipolar.